Alright, we're working limits, solving them analytically, and we're going to talk about the trig functions. Um, and I'm going to start with the limit as theta approaches 0 of sine theta over theta. Now, this is one that you just memorize, that when we have the sine theta over theta, as theta goes to 0, you need to remember that that's just equal to 1. Okay, so keep that in mind, that this is equal to 1. And it's just because. Now that we know that, let's look at a different one. Okay, so we have 5, and then in parentheses 1 minus cosine x over x. We did the direct substitution. That's supposed to be a 0 there. Over 0. And the cosine of 0 is 1. So we have 1 minus 1 inside. And that's going to end up being 0. And 0 times 5 is 0. So we end up with 0 over 0. So that means that we're going to need to try to rewrite this. And we're going to do just that. So, what I'm going to do here is what's going to look like a trick of some kind, but it's multiplying the numerator by its conjugate. I'm going to take this 5 and just bring it outside and get it out of the way. The thing is in the way. So I have 1 minus cosine x, and I'm going to multiply that by 1 plus cosine x. Over one plus cosine x. Okay, so now what I'm going to do is multiply the top, and you're going to end up getting 1 times 1, which is 1, and 1 times cosine x plus negative cosine x times 1, which they're going to cancel out, and then you're going to end up with minus cosine squared x over x times 1 plus cosine x, and boy, don't forget to rewrite your limit. That'll definitely get you a mark on your paper. Okay. Well, 1 minus cosine squared x, remember, is sine squared x. So I'm going to replace all of this with a sine squared x. And of course, we've got to continue to rewrite the limit. What was that here? Oh. We had sine squared x, which Okay. Now I'm going to break this sine squared up x up. So we're going to rewrite this. Now remember that all these limits are equal to each other. So this becomes sine x, and I'm going to break it up and put the x up underneath there like that. Now we just talked about this earlier, what that's equal to. And then we have sine x over 1 plus cosine x. Okay, so I have the 5 times. Now we can separate these limits because, right, we've got these two guys multiplied by each other. But instead of separating the limit and rewriting all this stuff again, I know that the limit as x approaches 0 of sine x over x, we said was defined to be 1 times, and I plug the 0 in up here, and the sine of 0 is just 0. And we have 1 plus cosine 0, and that's going to end up making that 2 in the bottom because cosine 0 is 1 and 1 plus 1 is 2. But we end up with 0 over 2, which is just 0. So finally, we end up with 0 as our final answer. So we can come back up here and say that this limit is equal to 0.